Hi, welcome to another nostalgic math ramble. Today we are chatting about IEB's November 2023 paper 2, question 11. I think we just have 2 more questions to go on this exam. Anyway, fun fact. Okay, question 11. Let's do it. In the diagram below, the equation of the circle with center C is x squared plus y squared minus 12x minus 4y plus p is equal to 0. Cool. AO, OB, and AB are tangents to the circle. Okay, so AO, OB, and AB are tangents to the circle. Okay, and then the point B is 12, 0. Right. And then the first thing we're asked is to figure out the value of P. Fun times. So, I think we're definitely going to need to do the completing the square situation to get it into standard form. How we will then get P is not clear to me. I guess it has maybe something to do with getting that point. We don't know what these points are. Okay, but we are going to get the center of the circle when we do completing the square. We're going to get this. Oh, okay, I see. So we're going to get the center of the circle, and then we will know the length of the radius, because we know that the circle touches the x-axis. So once we know what the okay, and why do I assume? Well, okay, yes. So, okay, the question I was going to ask myself is, why do I assume that this point and the center are in a perfect straight, well, not a perfect straight line, but a perfect vertical line? And that is because we've been told that OB is a tangent to the circle at, yeah, so, so there is a point on OB that is also on the circle, i.e. there is a point on the x-axis that is also on the circle. And if I connect the center to that point, we know that that is 90 degrees because of tan rad. And because this is 90 degrees, we know that this guy and this guy are in a perfect vertical line. So whatever, so if I know what the coordinates of C are, I know that it is, so say for example the coordinates of C are 5 and 3, right? Then I know that this distance is just then 3 units, because C is 3 units above this point. Okay, yeah, belabored the point, but I hope it makes sense. Okay, so what I'm going to say then is just to kind of, let the examiners into my brain. I'm going to call this point P. Well, yeah, maybe P is too close to that P. This P over here, this P. Okay, so I'll call it another letter. I'll call it Q. Right, and so I'll explain what Q is. I'll say let Q be the point where tangent OB contacts the circle. Possibly don't need to say this now. Well, okay, but anyway, let's see it through. And therefore, CQ is perpendicular to OB, and that is because of tan rad. Right. Okay, so I've shown that there's that relationship. Okay, Cool. So we've established that. We'll come back to it just now. So let's park it. Let's now get into the colorful work of completing the square. I'm going to write on the diagram and just hope it doesn't come back to kick me in the butt. Okay, so I'm going to start by rearranging this so that my XE terms are next to each other and my YE terms are next to each other, and I'm going to move the P to the other side, so it'll become minus P. Then I'm going to not do this so close because I'm going to need a lot of space. So I'm going to say x squared minus 12x plus negative 12 over 2 squared plus y squared. I underestimated the space I needed. Okay, I'm going to rewrite this here. X squared minus 12x plus negative 12 over 2 squared plus y squared minus 4y plus negative 4 over 2 squared. And then add those same terms on this side. Because I'm running out of space, I'm just going to evaluate what these are. Negative 12 over 2 is negative 6. Squared is positive 36. Okay, and this one is negative 4 over 2, which is negative 2. Squared is positive 4. Okay, right, so now we've added the same term on both sides of the equation, meaning everything is still in balance. Okay, oopsie daisy. Okay. What's going on? Anyway, fine. Alright, okay, then this we can easily factorize. We just say x, and whatever this term is, add that, so that'll be x minus 6 squared. And likewise here we have y, and then add this term, well, whatever is inside the bracket, so we're going to add a negative 2, or y minus 2 squared is equal to minus p plus 40. Okay, so what does this tell us? This tells us that the center of the circle, its coordinates are 6 and 2. So this is 6 and 2, right? And so therefore, the coordinates of Q, well, more specifically, the coordinates of Q are going to be 6 and 0, right? And that's because we showed that CQ is perpendicular to the x-axis, right? And so, yeah, that means that just to make it abundantly clear, that tells us that CQ is parallel to the y-axis, okay, which tells us that these points are really directly, the one is directly above the other or directly below the other. Therefore, we can assume that the x-coordinate of Q will be exactly the same as the x-coordinate of C, right? And so therefore, the radius of the circle is 2 units, right? And so, therefore, minus p plus 40 is equal to 2 squared, right? R squared, which is 4. Okay, this we can also just write as 40 minus p, right? What do you need to subtract from 40 to get 4? That would be 36. So the answer is that this guy is 36. Right. Okay, let's just double check with the memo before we go too far. P is 36. Yes, fantastic. And same workings. Yeah. Cool. Determine, okay, first let me just write down what we know so far. We know that our equation for the circle is x minus 6 squared plus y minus 2 squared is equal to 4. So we know that this is 6 and 2. I don't really know if we need q again, but yeah, whatever, we'll keep it. Right. Okay, cool. So determine the equation of AB, show all your working. Okay, AB. Okay, so this is a tangent situation. Interesting. So we don't know what are the coordinates of that point. Okay. So I'm looking at this tangent and this tangent and thinking, okay, well, and not specifically from here, from this point of contact, right? These two are the same length because they meet at the same point B, and we know that this length is 6 units, so I don't know if this can help us. It's just one thing that comes to mind. Well, I then thought, okay, we have the radius, the length of the radius, 2 units, so we could do some Pythagoras to figure out the length of that, but where are we going? Where are we going? I mean, we could say that, we know since this point is on the circle, right, we have an expression that connects its x and y coordinates, and we could also, using the distance formula, have another expression connecting, its x and y coordinates with this guy and saying, well, that's equal to 6. I don't know if that's too dramatic. But yeah, once we know what the coordinates of this point are, then, we can get the equation of the line. So I'm just going to try that and see if we end up with a scary expression or an okay expression. Oh, my eye. Okay, so let's see. So I want to write an expression for this. That distance, so let's say, let's just temporarily call this T. So TB, and let's say its coordinates are A and B. So TB will be equal to 12 minus A squared plus B minus 0 squared. So that will be 12 minus A squared plus B squared. And we would know that TB is 6. I'm just writing it out in rough as a start. And if it looks like it will give me something, I'll come back and tidy up. So that would be one of the equations. The other equation would be, well, A minus 6 squared plus B minus 2 squared is equal to 4, because we know that T lies on the circle. So that is going to give us quite a, messy, it's going to be a messy simultaneous equation system, because once I expand this, well, we know what it looks like. It looks like this. So we're going to have an A squared term, a B squared term, an A term, a B term, And from this, we're also going to have an a squared term, an a term, and a b squared term. So I don't know how I'll get rid of the b term that comes out of this, because I can rewrite this so that b is the subject of the equation, but then we're dealing with roots, right? We're going to have b is equal to a root, and then I have to substitute in here and do a multiplying out dealing with the roots. That doesn't feel right. So I'm going to resist that path for now. Just slowly step away from a scary situation. I'm also just going to rub this out so that it doesn't mess with my piece, and also so that I can just have time to think through this a little bit more. Oops. Determine the equation of AB. Tangent. What are you saying to me, tangent? Are you saying anything at all? Is it worthwhile to try and figure out the coordinates of A? How would I even do that? Where would I begin? So I mean, the diagram suggests that A is right above the center of the circle. But do I have any grounds to believe that? Well, let's see. So if I connect A and C, I don't know. I don't even know if it's worth thinking about that, honestly. Yeah, but if something else suggested, I will revisit. I mean, so one of the things that's also clear to me is, okay, OQ is also 6 units long, right? So these are all equal, and we know that, if we kind of put that point there, the point where OA contacts the circle, that this is also the same length. And then finally we have these two little bits at the top that are also the same length, because, right, tangents meeting at one point. So overall, this guy is the same as that guy, the same length, right? Is an isosceles triangle. Yeah. It's just something that's there in my mind. Um, mm, so, I mean, if I draw a line connecting A and Q, okay, then this line creates congruent triangles AOQ, AOQ, and AQB, because this length is equal to this length is obviously common, and then these two are equal, so then they're congruent, which means that this is 90. And because we know that C and Q are also perpendicular, then we know that that line goes through the center of the circle. And then what can I determine from there? What can I do? What can I do? So, I mean, yeah, this is just me like drawing random things, and I'm also just trying to be intentional about like articulate every thought that goes through my head, even if it feels very random and like dead end. But if I connect these 2 points over here, right, because triangle AOQ and triangle ABQ are congruent, I know that these angles here are equal. I've shown that these two green sides are equal. This side is common. So using SAS, I know that these two triangles are also congruent, meaning that this little length over here is the same as this little length over here. So I have a line through bisecting a chord, meaning that this is a 90-degree angle, and also that would mean that that line is parallel to the line to the x-axis. So these 2 points are in a perfect horizontal line. So whatever the x coordinate of this guy is, we know that his y coordinate is definitely b as well, same as the coordinate t that we've drawn. Yeah, no, it's a bit bleak. I won't lie. What else can I say? So yeah, moments like these, I miss being a teacher, where my kids would just be in the classroom like, Miss T, this is what's going on. I'm like, oh my goodness, how did I miss that? precious moments, man. Okay, what am I hoping for? Maybe if I kind of say what I'm hoping for, I can manifest it. I am hoping for the coordinates of A. That would be great. How could I get the coordinates of A? Well, I'm kind of halfway there. I know that the x coordinate of A is 6 and something because I've shown that A, C, and Q lie on the same vertical line. So their x coordinates are all the same. So I just need to know what its y coordinate is. Yeah, that would be great. So how could I find its coordinates? Well, if I could find the length of CA somehow, that would be a great help. How could I find the length of CA? I could draw the radius CT and I would know that that's true, but I wouldn't know what is the length of TA. I also see that, we have these two triangles being similar, but the only length I know in any of those triangles is the length of this guy, which is 12. And I wouldn't know how to figure out the scaling factor to get down to this little triangle. I'd need a hint from this triangle. Oh, this side is now this much smaller. Yeah. Otherwise, I could also settle for getting the coordinates of T. How could I find those? Well, I had my little distance pipe dream, which was promising to get messy, but hey, desperate times might just call me back there. Does this line do anything for me? I don't know. This line we know is 2 units long. And I mean, another relationship I could draw up is that the gradient of this line is equal to the negated reciprocal of the gradient of this line. So that's one relationship I can draw up. And that is potentially a relationship. Yeah, that's a simultaneous equation I can use, and that won't be messy. Okay, yes, right. Jeez, man. Okay, so I'm just going to get rid of all this other colorful stuff I've filled in all of my deliberating and agonizing. Yeah, let's just get rid of all this other stuff and only bring it back if we think we might care in future. Okay. Right, so I am going to start by saying, explaining who is T. So I'm going to say in another color, let T be the point on the circle where tangent AB touches the circle. It's not a great sentence, but yeah. Okay. Let T have coordinates AB, right? So then we know 3 things about T, but the easy, or not easy, but the kind of nice expressions to work with. Yeah, and I actually might just avoid using this, because using the distance thing that I had drawn up first, we ended up with 12 minus a squared plus b squared, whereas here we're going to end up with a minus 6 squared plus b minus 2 squared. That's, yeah, the other one has less bracket expanding to do. So I'm going to go with the gradient relationship and the distance relationship. So let me start by writing down the gradient relationship. So I'll say number 1, gradient, okay. We know that the gradient of CT can be expressed as b minus 2 divided by a minus 6, right? And the gradient, oh, this might not be as nice and clean as I had hoped it would be, but anyway, the gradient of TB is going to be b minus 0 over a minus 12, or b over a minus 12, right? And what do we know? We know that because CT is perpendicular to TB, and that's because of tan, right? We then know that b minus 2 over a minus 6 is going to be equal to, flip these around and slap a negative in front of it, right? So it's going to be equal to that, which is, if we do a, okay, first I'm going to use the negative to do a switcheroo up here. Okay, right, because remember the negative could either go up there or it could go down here. So I'm going to take it to the top, and if I multiply a negative over in there, the a becomes negative, the negative 12 becomes positive. Anyway, okay, right, so b minus 2 over a minus 6 is equal to that, and if we then cross multiply, we end up with b times b minus 2 is equal to a minus 6 times 12 minus a. Ooh, yeah, this is not giving me the nice clean equation I'd hoped for. So this is b squared minus 2b is equal to 12a squared, no man, 12a minus a squared minus 72. Okay, gonna need to move this just to make space for one last term, which is plus 6a. Okay, I'm just going to put this all on one side so I can just see what's going on. So this is a squared, 12a plus 6a is 18a, so this will become minus 18a, and then plus b squared minus 2b plus 72 is equal to 0. So that would be one equation. Okay, all of a sudden this doesn't look so scary anymore. Okay, so this is another thing that we know about T. Because it lies on this circle, we know that if we sub this in here, right, that equation will be true. So let's write that down. So we know that, so let me say 2 lies on circle Okay, so we know then that a squared plus b squared minus 12a minus 4b and P we found to be 36 is equal to 0. Okay. And I think we can subtract these two equations so that we get rid of the quadratic terms and we're just left with the linear terms, and that might give us a nice, that will give us a nice linear equation to use instead of using the two bombastic equations. Okay, the third thing we know is the distance stuff, right? So we know that QB is equal to TB because tangents meeting at one point are equal. I don't know what the official reason for that theorem is, but I think that's detailed enough for me to get a pass. And we know that, okay, QB has a length of 12 minus 6, which is 6. And so therefore TB is also 6 units long. Okay, but another way that we could express the length of TB is by saying, using the distance formula. So TB is equal to the square root of, and we have B, well, let's start with the x coordinates, A minus 12 squared plus B minus 0 squared, right? So that means 6 is equal to that. Okay, so 36 is equal to A minus 12 squared plus B squared. Okay, right. So now let's label our equations. So we have here equation 1, equation 2, and equation 3. So I'm going to start out by subtracting equation 1 from equation 2, whatever. Yeah, maybe let's do equation 2. No. Yeah, okay, let's say equation 2 minus equation 1. I was trying to see which one will help me end up with more positive coefficients, but we can always just change them to positive coefficients by multiplying through with -1. So really doesn't matter that much. So we've got a squared plus b squared minus 12a minus 4b plus 36 is equal to 0. And we're going to subtract a squared minus 18a plus b squared minus 2b plus 72 is equal to 0. Okay, right, so a squared and a squared minus a squared is just 0. B squared minus b squared is 0. Then we have minus 12a minus 18a, so minus 12a plus 18a, which is positive 6a. Whoop whoop. Got me my positive. Hello. So that is positive 6a. And then we've got minus 4b minus 2b. So minus 4b plus 2b, which will be minus 2b. Okay. Right. And then lastly, we've got 36 minus 72, which is negative 36. Okay. And then we can simplify our equation by just dividing through by a 2. So that will be 3a minus b minus 18 is equal to 0. And that can become our equation 4. Right, and so now I can work with this guy and solve simultaneously. Whoop whoop. Exciting! This is really so exciting. I'm so excited. Do not undermine your leads. Okay, right. Cool. So, using equation 4, so I'm going to rearrange 4, and I'm just going to, yeah, B looks like the easiest to make the subject of the formula, so I'm going to move this guy to the other side. So 3a minus 18 is equal to b, so that's an expression for b in terms of a, so I'm going to sub that into equation 3. So then I've got 36 is equal to a minus 12 squared plus 3a minus 18 squared. Okay, so now it's time to do some bracket expanding. So that'll be a squared minus 12a minus 12a plus 144, that's minus 12 times minus 12. And then over here, I'm just going to quickly factor out 3 so that I can make my life slightly easier. Adds a few more lines of computation, but yeah. So that'll be 9 times a minus 6 squared, right? So that is a squared minus 24a plus 144 plus 9 times a squared minus 6a minus 6a. And then minus 6 times minus 6 is positive 36. So a squared minus 24a plus 144. And I'm just going to write this here for ease, plus 9a squared minus 108a plus 36 times 9. So that's 360 minus 36, which is 324. Right, and that simplifies to 10a squared minus 132a plus 468, right? And this is equal to 36. So get this guy onto the right hand side, so that'll be 0 is equal to 10a squared minus 132a plus 468 minus 36. So that is 10a squared minus 132a plus 432. Yeah, the highest common factor I can divide through with is 2. That doesn't really make my life great, so I'm just going to stick this into the quadratic formula as is. So a is, A is equal to minus b, so minus b plus or minus square root of that guy squared minus 4 times 10 times 432 divided by 2 times 10. Yeah, my fear with these bombastic workings is to get to the end and find that your baby girl went on a full a full tangent. What am I doing? Whoa. Okay, but let's see. Crossing fingers, yo. Okay, so option number 1 is a is equal to 7,2. Oh, that looks weird. Okay, so that would be 36 over 5. Okay, actually 7,2 is just more intuitive. 36 over 5 is not giving me warm fuzzy feeling. How do I backspace? Oh, Dell. Anyway, now I have to type this again, looking at the minus solution. Mm-hmm. And over there we get A is equal to 6. Right. Well, okay. So those are our solutions for A. And let's see what our solutions then for B are. So I'm going to put it into this equation. So therefore, B is equal to 3A minus 18. 3A, no man, 3A, so either 7,2 minus 18 or B is equal to 3 times 6 minus 18. So that would be 21,6 minus 18, which is 3,6. And over here we have 18 minus 18, which is 0. Right. So if we then look at our circle, well, it clearly isn't the one with the y-coordinate of 0. So it would be the other one. But I don't feel lacquer because why are there two solutions to begin with? If there are two solutions, then I'm expecting to see 2 points that have exactly the same conditions as described by the 3 equations that, you know. So it would have to be the gradient of that point and the line connecting that point to B. So it would have to be a point where they are perpendicular. So I mean, okay, I'm instinctively then looking at this guy, but that gradient is undefined, so that is not we don't have. Could there be another tangent from B? Could there be another tangent from B? I don't see how. Like I can't physically, you know, because once we go below the x-axis, that line is never touching. Is never going to touch the circle. So it's this one or it's that one, and that's it. But yeah, other than the gradient thing, well, this point does also lie on the circle, and the distance from B to Q is also 6. But then I would have expected the solution to point to this point, to point to 6, 0, but it doesn't. It does point to 6, 0. Funny. Okay, so either the point is 6, 0. Oh my goodness, I can't believe. Yo, what time is it? Let me just blame the time again. So our simultaneous equations are telling us that this is a point that satisfies these requirements, although it would fail this condition because when x is 6, or if A is 6, then this gradient becomes undefined. So Q really isn't actually a solution for this system of equations. So actually it would have been more responsible to mention that over here already, right? That A can't be equal to 6, even though we can see that the point T doesn't, it on the diagram doesn't look like its x coordinate could be 6, but to be mathematically correct, the variable a cannot take on the value 6. And likewise over here, we would just be responsible and mention that a cannot take on the value 12, right? And just basically everywhere where there's a division, it would be responsible to put in restrictions on the equation. So here we would have to say b can't be equal to 0, otherwise our equation falls apart. So by seeing those restrictions, it then helps us to say, but okay, this solution fails because we said in the beginning a can't be equal to 6, b can't be equal to 0. Anyway, so we can say here, but a can't be equal to 6. So in fact, we would write that here. Right, and that's from an earlier restriction that we put in. Right, but even if let's say you hadn't thought to indicate these restrictions, like me, right? So you would have worked out that, okay, the two possibilities are 7,2 and whatever we found, and 6 and 0. But then we would say, but T is not Q. It's just not. It's not that they're not the same point. So that would disqualify that solution, I guess. I don't know if it would be adequate to say that. Doesn't feel adequate, but I think for high school it would be adequate. Anyway, so that would eliminate us having to explore that. So therefore, T has the coordinates 7,2 and 3,6. My goodness, if this is not right, I will cry. Anyway, I now need another page because all of this long working is for us to figure out the equation of line AB. I am just so sure that there's a simpler way to solve this question. And I'm fully ready to kick myself in the butt when I see what it is. Anyway, so we now have the coordinates of T. We know that B is 12, 0, so we can now figure out the equation of the line AB. So let's do it. So equation of AB, we will find the gradient of TB, which is 3,6 minus 0 divided by 7,2 minus 12. Okay, I'm going to bring my calculator out for that one. 7.2 minus 12. So that is negative 3/4. And then we can say, so y is negative 3/4 x plus c. And let's sub in the point b. So that will be 0 is equal to negative 3/4 times 12 plus c. 0 is equal to negative 9 plus c. And so c is equal to 9. So the equation of AB at last is y is equal to negative 3/4 x plus 9. Okay, so I really do just quickly want to run through what I've done. Firstly, for me to just double check my workings, but also just to kind of, give a summary, right? So first I decided to name this point T, the point where AB contacts the circle. So I called it T and said, okay, suppose its coordinates are AB. Then I gathered information. What do I know about this point T? So first of all, I know that this line CT is perpendicular to TB because of tan rad, right? So I can then use the fact that they're perpendicular to set up an equation in terms of A and B. So I found an expression for CT, which is B minus 2 divided by A minus 6, right? And then I set up a restriction there, right? This only works if A is not equal to 6. Okay, then I set up an expression for the gradient of TB in terms of A and B as well. So that would be B minus 0 divided by A minus 12, right? So that's just B divided by A minus 12. And again, restriction there being A can't be equal to 12. So because CT is perpendicular to TB, right, because of tan rad, I then know that this guy is equal to this guy flipped around and slap a negative in front of it. So A minus 12 divided by B, and I slap a minus in front of it. And of course, this only works if B isn't 0. We've also already indicated that A can't be 6. And then I did cross multiplying. Well, first I multiplied the minus into this top expression, so it switches these terms around. And then I cross multiply to get to just like, yeah, I didn't want to deal with fractions. So that gave me B times B minus 2 and A minus 6 times 12 minus A. So on this side, I have B squared minus 2B. And on this side, I've got 12A minus A squared minus 72 plus 6A. Okay. Then I add A squared on both sides. So I've got this here. And then 12A plus 6A is 18A. So on the left-hand side, it becomes minus 18A plus B squared minus 2B. And then this guy also comes across and becomes plus 72 is equal to 0. So that was now my first equation relating A and B. The second piece of information I used is the fact that this point lies on the circle. So if I put A and B into this equation, it will hold. And I mean, yeah, I just spared myself multiplying these brackets out again because we already kind of know what that looks like when it's multiplied out. That was our starting point for the previous question. So, right, so I just put in the A and the B there. So A squared plus B squared minus 12A minus 4B, and P we found to be 36 in the previous question, so plus 36 is equal to 0. All right, so that's my second equation connecting A and B. Then the third equation connecting A and B, well, I used the fact that, okay, TB and QB are going to be equal in length because they are two tangents meeting at a common point. And we know that QB is 6 units long because we're going from 6 to 12 on the x-axis. So then TB has the same length. So then I use the distance formula to write an expression for this. So that was, I wish I could shrink the screen sometimes. Anyway, so that was the x-coordinate of t, a minus 12 squared plus b minus 0 squared. The square root of that is equal to 6. And then I square both sides, right, to get rid of this root. And I just then have 36 is equal to a minus 12 squared plus b squared. So I now have 3 equations, which is abundant. To solve for 2 variables, right, you should only need 2 equations. The reason why I wanted 3 was because I wanted to use these 2 to get to a linear equation, because that I can easily rearrange to substitute into a third equation. And honestly, I could have minused this one from this one, right? That would have also gotten rid of the quadratic terms and just left me with a linear expression. So, right, anyway, I chose to subtract this equation from this one. So we had a squared plus b squared minus, whoa. Oh, okay, yes, I subtracted this one from this one. Okay, so we're starting with this one. A squared plus b squared minus 12a minus 4b plus 36 is equal to 0, minus a squared plus b squared minus 18a minus 2b plus 72 equal to 0. Okay, so then we had a squared minus a squared is 0, b squared minus b squared is 0, minus 12a minus 18a, so that's positive 18a minus 12a, which is 6a, minus 4b minus 2b, so that's positive 2b minus 4b, which is minus 2b. And then 36 minus 72 is minus 36, and 0 minus 0 is just 0. So, yeah, so then we got that. Then I just divided through by 2, so I have 3a minus b minus 18 is equal to 0. Whew, okay, so that is now a fourth equation, the linear equation I wanted, which I then rearranged to so that b is the subject. So just add b on both sides. So I've got 3a minus 18 is equal to b. Cool. Now I can take this expression and sub it into this equation, right? So I would then have a minus 12 squared plus 3a minus 18 squared is equal to 36. Multiply this out, a squared minus 24a plus 144, factored out to 3 over here to make my life a bit easier. So that's 3 times a minus 6 gives me that, and we need to square that. So square the 3, square the bracket, 9 times a minus 6 squared, and then this became 9 times a squared minus 12a plus 36, and then multiply that out, and I get 9a squared minus 108a plus 36 times 9. 36 times 9, 36 is the same as 18 times 2. 18 times 2 times 9, 18 times 18 also gives me 324, so that looks good. Add these all up, we get 10a squared, 108, 24, 128, 132, cool, minus 132a, and then 468, right? And then we minus 36 on both sides, so this leaves us with 432. Yes, sub it into the quadratic formula, so minus b plus or minus b squared minus 4ac, not to be confused with this a, oof. And then 2 times a at the bottom, right? And those are the answers we got. And we eliminated this guy because of the earlier restriction, but also it just, yeah, it couldn't be. So sub that back into this guy, 3a minus 18. So we have 3 times 7,2, which is 21,6, minus 18, 3,6. So the coordinates of t are that. And then I'm not going to double check this. I'm pretty confident about this. Finding the gradient of TB to be that, and then subbing in B. Yeah, okay, I think I'm fine with this. If I've gone wrong somewhere, it's earlier. It's not here. I refuse. Right, let's see. Memo, the grand reveal. Sure, it is definitely shorter. So let's see what they've done. Right, so, and maybe I must actually just have this on a different page. So let me duplicate this one and move it up. Can I move it? I like to move it. Did I move it? Oh, I don't have to move it. Hey, sometimes I'm just so stubborn because these pages are exactly the same. Like, why do I have to move it? Right, let's delete here. Okay, and we know that this is x minus 6 squared plus y minus 2 squared is equal to 4. So this is 6 and 2, and we also have q, which is 6 and 0. What else did we know from the previous question? I think that pretty much it. Anyway, right. So what they did is, oh, rub my eye real quick. Draw CB. Okay. Draw CB. Okay. Oops. Overdid it. Okay, so we have drawn CB. Then the gradient of CB is 0 minus 2 divided by 12 minus 6, which gives us what? Negative a third. Yes. So it's negative 2 divided by 6. I agree, that is negative a third. So the gradient of that is negative a third. Okay, and then they say draw CD, radius perpendicular to tangent OB at D. O, radius, what? Radius perpendicular to tangent OB. Oh, so their D is Q. Right? Yes. Okay, so we constructed that for our previous question. Then sorry, I just got distracted. Right. So the tangent of CBD, tan of CBD is a third. Okay. What? How do we get there? Okay, I'm just going to rewrite this up here. So they said the gradient here is negative a third. Okay, we know that this is perpendicular, so I'm guessing we are using SOH CAH TOA. Okay, so tan of this angle over here is opposite, which is 2, over adjacent, which is 6. So tan of angle CBQ is a third, okay, which then results in them working out that CBQ is roughly, is 18,43 wara wara wara. Okay. Then they say triangle ECB is congruent to triangle QCB. Where's E? Who is E? Where does E come from? I mean, it makes sense to me that it would be that triangle. E, C, no, that doesn't make sense. I'm guessing E is this point. Okay, so if you then do that, right, they are congruent because this is also 90. They have the same, they have a common hypotenuse, so using RHS, they are congruent. Okay, so that tells us that this angle is also 18 degrees. What does it tell us, man? It tells us that DBA, or QBA in my case, is 2 times the 18, this guy, yeah. And so Okay, right. So then they get this angle by subtracting this from 180, which then gives them the angle of inclination for this line. So then they have the gradient, right? Because they can work out the gradient from that. And then they can get the equation of the line by subbing in B. Wow. Wow. I definitely really, I think in all of my videos, I am yet to use the angle of inclination like in a serious problem. It just doesn't come to my brains. Definitely underutilized, an underutilized tool in my toolkit. But this is very cool. So let me just run through that again without external assistance. Okay, so what we did was, I rubbed out too much. Anyway, okay, so what we did was we said, so essentially what we were trying to get was this angle. Really, that's what we were working towards. So then we constructed this guy. Well, from previously we constructed that, and we constructed this guy. Okay, and we knew that this is true. This is a radius of the circle, so it's true. And we know what this is. This is 6, because it's the distance between Q and B, which then allowed us to find this angle using tan, using SOH CAH TOA, right? Because this is a 90. Then we constructed this guy over here, right? And this is also a 90 because tan rad. And then we realized that these triangles, whoopsie, let's do it like this. This triangle and this triangle are congruent. Why are they congruent? They're congruent because we have a 90 in both triangles. This side is equal to this side because they're both radii and they have a common hypotenuse, so they are congruent, meaning that this angle over here is equal to this angle over here. Okay, which we could then use to find this angle. And once we had this angle, we were able to find the gradient of this line because we had the angle of inclination. And so once we had the gradient, we could then find the equation of the line by subbing in the point that we know. Wow, okay, sure. Sure, yeah. I mean, I've confessed before that I'm a paper 1 girl. I am forever going to approach a question using algebra over anything else. But this is also showing me, like, don't be afraid to draw, don't be afraid to construct. Interesting to see a more geometry-based approach to the question as well. Okay, wow, there's more. Right, the last question. Come on, don't bri us. I am not in the mood. I feel like we're already over an hour, I'm sure. Anyway, so we have a second circle with center. Okay, wait, I'm just going to write down this is 6, 2. And this is y is equal to, oh, battery is even fading on me. Okay, right, we have a second circle with center 0, 9. So that'll be, let's just say somewhere up here. Okay, right, which is the y-intercept of this line, if we were to extend it. Okay, and it has the point 2, 3 on it. 2, 3 might be maybe somewhere here. So that is a circle like this. Okay. Do the two circles intersect? Okay, so this is a straightforward one, right? We want to find the length of the radius, okay, which we can find by calculating that distance. Then the next thing we do is we find the distance between this center and this center, right? And if we find that that distance is greater than this radius plus, a radius from this circle, added together, then we know that they don't intersect, right? So if this radius plus this radius is not equal to the distance between these two, well, if it's smaller than the distance between them, then we know that our circles overlap. If it's exactly equal, then we know that our circles just touch once. Otherwise, if that distance is greater than the sum of the radii, then we know our circles don't touch. I already have a feeling they don't touch, but anyway, who am I to judge from a diagram? So we need to find the radius of circle 2, okay, which is r is going to minus, so say 0 minus 2 squared plus 9 minus 3 squared, which is 4 plus 36 under the root, so that's root 40. Okay, and then I'm going to find a distance between two centers. So that would be, that distance is, let's say 0 minus 6 squared plus 9 minus 2 squared. So that is 36 plus 49, which is the square root of 85. Okay, right. So now we want to see, well, let's say, so let's call this radius 2. R1, this is a radius of circle 1. Okay, so R1 plus R2 is equal to 2 plus root 40, and let's work out what that is. 2 plus root 40 is 8, 3, 2, blah blah blah, and the distance between the two circles is the square root of 85, which is 9, 2, 1, blah blah blah. So because the distance between the two centers is greater than the sum of the two radii, that means that the circles do not intersect. Oh, okay, that was definitely a nice cool down from that Adha marathon. Thank you for sticking around. I hope it was a useful, I never know whether to call these lessons, but yeah, it's a ramble. It's a ramble, that's what it is. I hope it was a useful ramble, especially to see a completely different approach to the question than what is shown in the memo. And yeah, hope you will come back again and join me for another chat.